A caiman sits under the water, completely still, for over an hour. No breath, no movement, no visible pulse of life. Every animal drinking nearby assumes the water is empty. In the next few minutes, you'll learn exactly what's happening inside that motionless body and why that stillness is the deadliest tool in its arsenal. The spectacled caiman lives across Central and South America, in swamps, rivers, and slow-moving wetlands. It's smaller than its larger crocodilian relatives, rarely exceeding 8 feet. But size was never its advantage. Patience is. And to understand its stillness, you first need to understand what its body is actually doing beneath the surface. This isn't rest. A resting animal still shows small signs of life, twitching muscles, shifting posture, subtle breathing. The caiman shows none of that. Its body becomes a statue. Even its eyes barely move. Something inside this animal is actively suppressing every normal biological signal. And that suppression is more extreme than most people realize. Reptiles don't process oxygen the way mammals do. A spectacled caiman can hold its breath far longer than any human, sometimes over an hour in calm, low-energy conditions. But that time isn't unlimited. Every second underwater burns through a finite oxygen reserve. So the question becomes obvious. How does it make that oxygen last so long? Here's the first real answer. Scientific studies on crocodilian physiology confirm their heart rate can slow dramatically during submersion, a response called bradycardia. Some recorded rates drop below 10 beats per minute while submerged. That's a massive reduction from their normal resting rate. A slower heart means slower oxygen consumption, and slower consumption means longer survival underwater. But slowing the heart isn't the whole story. Research shows crocodilians can redirect blood flow away from less critical organs during dives, prioritizing the brain and heart. This isn't accidental. It's a controlled physiological response, refined over millions of years of evolution. Essentially, the caiman's body makes a calculated decision about where oxygen matters most. Movement burns oxygen fast. Muscles working underwater consume reserves the caiman desperately needs to conserve. So stillness isn't just about hiding, it's about survival math. Every twitch, every unnecessary motion, shortens how long it can stay submerged. The caiman isn't simply choosing to be patient. Its own biology is forcing patience as the only option. If stillness is purely about oxygen conservation, why does it so often happen exactly where prey animals gather to drink? That timing feels too precise to be coincidence. Something else has to be happening here, layered on top of the physiology. And that's where this story turns from biology into pure predatory strategy. Spectacled caimans are classic ambush hunters. Unlike animals that chase down prey across open ground, they rely on surprise, striking from concealment rather than pursuit. Stillness isn't separate from hunting. It is the hunting strategy. Every second of motionless waiting is an investment toward one explosive, split-second strike that prey never sees coming. The caiman's coloring, mottled greens and browns, blends almost perfectly with murky water and shadowed vegetation. Combine that camouflage with total stillness, and the animal essentially disappears, even in shallow water, where prey should have a clear view. Nature didn't just give this predator patience. It gave it patience paired with near-total visual concealment. Here's what makes this so effective. Approaching animals rely heavily on movement detection to sense danger. Their eyes are tuned to catch motion, not stationary shapes. A caiman holding perfectly still, partially submerged, doesn't register as an active threat. To a thirsty deer or a waiting bird, it can look like nothing more than a log. Researchers studying ambush predators found something that changes this picture entirely. The stillness isn't just passive waiting. Sensory data suggests these animals remain highly alert during submersion, tracking vibrations and movement in the water, despite showing zero outward physical response. In other words, the body freezes completely, while the senses keep working overtime. Crocodilians, including the spectacled caiman, have specialized pressure receptors across their jaws called dermal sensory organs. These structures detect minute vibrations and pressure changes in water, even in complete darkness or zero visibility. So while the body stays frozen, this sensory network is actively scanning the water for the exact right moment to strike. This sensory system essentially turns the water into readable information: a ripple from a bird landing, a vibration from a fish swimming closer, a pressure shift from something wading in. The Caiman doesn't need to see its target clearly. It can track it through vibration alone, calculating distance and direction before ever making a visible move. Chasing prey costs enormous energy, and success rates for pursuit predators are often surprisingly low. Ambush hunting flips that equation. By waiting motionless and striking only when success is near guaranteed, the Caiman conserves energy while maximizing its odds. Every failed chase is wasted energy. Every well-timed ambush is efficiency perfected through evolution. But this strategy carries real risk. A premature strike wastes stored oxygen and burns critical energy reserves for nothing. If the Caiman moves too soon or misjudges distance, it may need extended recovery time afterward and lose the advantage of surprise for any nearby prey. Precision isn't optional here. It's the difference between eating and starving. Stillness doesn't just help the Caiman hunt, it also helps it avoid larger threats. Juvenile caimans, in particular, face predation risk from birds, larger reptiles, and other caimans. Remaining motionless and hidden reduces the chance of being detected by something bigger. In this ecosystem, patience protects you from becoming prey just as often as it helps you become a predator. Popular wildlife content sometimes frames this stillness as almost supernatural, implying the Caiman enters some trance-like sleep state underwater. That's misleading. This is not unconsciousness. It's an active, tightly regulated physiological state. Heart rate reduced, blood redirected, senses fully engaged. Calling it sleep erases just how demanding this process actually is. Long-term field observation shows this behavior isn't random or occasional. It's a core, repeated hunting pattern used consistently across individuals and populations. Researchers tracking Caiman activity note submerged ambush waiting as one of their primary foraging strategies, especially in areas where prey regularly approaches the water's edge to drink or forage nearby. Every part of this adaptation, slowed heart rate, blood redirection, dermal sensory organs, camouflage, developed because ambush hunting outperformed constant pursuit in these environments. Caimans that could wait longer, sense better, and strike more precisely simply survived more often. Over generations, that advantage compounded, producing an animal built almost entirely around the power of doing nothing. When the moment finally comes, everything changes in an instant. Stored energy releases in a single explosive lunge, jaws closing with tremendous force before the target can react. The transition from absolute stillness to violent motion happens in a fraction of a second. That contrast is precisely what makes the ambush so lethal and so hard to anticipate. So why does the spectacled Caiman stay motionless underwater for so long? Not sleep, not simple hiding. A precisely engineered biological state, slowed heart rate, redirected blood flow, and an active sensory system working in total silence. Stillness here isn't the absence of action. It's the most calculated form of action this predator has. The next time you look at still water and see nothing, remember what you just learned. Nothing is rarely nothing in nature. It's often patience, calculation, and a body working harder in stillness than most animals do in motion. If uncovering the real science behind nature's most misunderstood behaviors interests you, subscribe now. The next investigation reveals something even more surprising.